Hey guys, in this video I am going to go through how to use the custom skateboard design tool on the Open Source Boards website. So the first thing to do is go on to opensourceboards.com, and just on the home page, if you scroll down, there is a link right here for designing your own board. So go ahead and click on that, and it's going to open up a page with the board builder. One thing I skipped, it's really important to use either Mozilla Firefox or Google Chrome. These are the only two browsers I've really tested it out with where it works well. So try and use one of those two browsers. It might work in some other browsers, but these are the ones that I know it works pretty well with. So as you can see at the top of the screen, it says it is rendering. Now it's loaded. The rendering time is about, it varies depending on where you are doing this. But let's look at the overall page here and what we have and go through it, and then we'll play around with some of the parameters that you can change around, and I'm going to go through how each of those parameters affects the shape of the board. So at the top of the screen, once the design has loaded, we have this yellow area and it says ready, and then there's a little button that says generate STL. The cool thing about this, or one of the cool things about this, is you can create STL files from the skateboard that you create, which is awesome because then you could just send them to a 3D printer or a milling machine, any CNC machine, and basically prep the files. So this main area where the board appears, I'll refer to that as the viewer area. You can change the view in the viewer area, change the camera angle by just left clicking on your mouse and dragging. You can also scroll in and out, and you can also pan. And in case you forget any of these controls, there's a little controls button right here, and it tells you to orbit or rotate is left mouse click, to pan is shift and left mouse click, and to zoom is the scroll wheel or control and left mouse click. So panning is basically moving side to side like that. So you could zoom in on different areas and look at the board from different ways. And the last main thing here is this parameters box. You can click and drag it, and there are different parameters for the different features of your board. So let's go through and change each of these up and see how they affect the board. So the first one's pretty easy. It's just the width. So as you imagine, this is going to make the board skinnier or wider. So let's change it to 10 and see what happens. And the way you have to update this is you click on the update button in the parameters box. You can also check the instant update, but I prefer to make all my updates or make all my changes and then update rather than have it re-render every time I change a number. So once I click on update, the board disappears and the text at the top here changes to rendering, and it's got a little loading symbol that shows us that it's working, it's thinking, it's trying to create this. And now hopefully you can see the board's a little wider. So that is a 10-inch wide board now. Now I'm going to go back, make it back to the original 8.25, and this time I'm going to change up the wheelbase. The wheelbase is the distance between the inner bolt holes. As you can see, there's two sets of bolt holes for your trucks. The inner bolt holes are the holes closer to the middle of the board. I'm also going to refer to the outer bolt holes later, and the outer bolt holes are the bolt holes closer to the ends of your board. So the wheelbase is the distance between the inner bolt holes, and this has an impact on the length of your board. So if I made the wheelbase 18, the board will get longer. So now you can see the board is much longer than it was before. Also, I just want to remind you that I am editing this video. The normal rendering time is about 10 to 15 seconds, and rather than just having me kind of sit here and making you guys wait for the 10 to 15 seconds, I'm going to edit that part out. So let's put the wheelbase back to 14, and now let's change the concave radius. So if you notice, if we look at our board, if we look at it down the length of the board, you can see that there's an arc to the deck. That arc is part of a bigger invisible circle, and that circle is defined by a specific radius. That is the parameter that you change for adjusting how much concave you have, how steep or how flat the board is in the middle there. Generally, I recommend the concave be no smaller than 16 inches and no larger than 60 inches. You might get some weird rendering things otherwise, and your board might be, especially when you go under 16, it might come out really weird. And remember that the bigger the radius, the flatter the board, because the bigger the circle is. So let's change the concave radius to something that might be steeper, because this is actually a pretty medium concave. So let's change it to something steeper where you can get a bigger exaggeration. So let's change it to 10, and this is going to be probably a pretty extreme concave. Alright, so this is a 10-inch radius concave, and like I said, this is actually out of the range that I recommend, but I just wanted to show you guys to demonstrate how this affects the shape of the board. You definitely don't want the concave to be less than half of the width. That just won't work out geometrically for you. Also, numbers larger than 60 may cause rendering problems, and 60 is creates a pretty flat board for most skateboard widths. Alright, so the next parameter, first I'm going to change the concave radius back to 20. And the next parameter is the nose length, and I'm going to actually bundle the next two parameters together, the nose length and the tail length, because they're the same dimension, or the same parameter, but just one's for the nose and one is for the tail. The nose and the tail length are the distance between the outer bolt holes and the nose and tail, respectively. So let's change those to see how they impact the board. So if you're wondering which side of the board the nose and the tail is, the nose is in the positive axis direction. So if you see here, there's a little red line representing an axis. The nose is along that right side, along the side of the red line. There's no red line on the left side, so that side is the tail. So let's change the nose length and tail length. Let's make the nose length 3, and let's make the tail length 8. Alright, so this is the board with the updated nose and tail length. As you can see, the nose is squished and it's cut off 3 inches away from the outer bolt holes, and the tail is a little bit longer than it was before. Let's put those back to the original values. And now let's change the kick nose angle and the kick tail angle. And these refer to the angle in the side view that the nose and the tail of our board come up at. So the larger the angle, the steeper the nose and tail are going to be. So again, let's change one of them to be greater than 20 and one to be less than 20. And I recommend, again, limits for this staying between 0 degrees and 45 degrees. So let's make the kick nose 0 degrees, so it'll be flat, and let's make the kick tail 45, which is the maximum that I recommend. So here's our board with our updated kick nose and kick tail angles. As you can see, the nose is totally flat and the tail curves way up to towards 45 degrees. Let's change these back to the original values again, and then play around with the last two parameters, the nose flatness and tail flatness. These are kind of bizarre parameters, but hopefully they'll make sense after I demonstrate what they do. If you notice, it says 1 equals flat, 0 equals sharp. You have to put in a number between 0 and 1. By default, it's set to 0.75. And what this changes is how square or how pointy the nose and the tail are. So to demonstrate this, let me put in the max and min values. So for the nose, I'm going to put in 0, so it's going to be a sharp nose, and then for the tail, it's going to be 1, so it's going to be a really flat, squared off tail. So this is what the nose and tail flatness do. As you can see, the nose is super pointy, super sharp, and the tail is pretty square. Let's change these one more time to see what else they can do. So I'm going to change the nose to 0.25, and I'll change the tail to 0.9 and update. So now you can see I made the tail a little bit less squared off, and I made the nose a little bit more rounded at the points, or at the corners rather. And that's basically a brief overview of how this tool works. Go ahead and play around with it, change up the different parameters, have fun designing your own board, and let me know if you have any questions or feedback in the comments.